Oops. Thanks for coming. So our Paco has already talked about the Azure Function stuff at the beginning. So it was really informational. Now we are doing the same Azure Function stuff again. But this is more about how Azure Functions works internally. So it's more about internal, how can I say, how internally Azure Functions working. And also, if we are using Azure Functions for your the serverless API application, then we probably need to consider those three things. Then we can build more effectively and efficiently. So that's throughout this session, we are talking about those things. Okay. Now, so my name is Justin, and I am the Microsoft MVP for both Azure and developer technologies. And if you are using social media, you can follow me on Twitter or visit my blog or LinkedIn, so wherever you like. And then you can receive some newest the Azure, the newest Azure news. So yeah, so also the thank you for our sponsors. So without them, this event wouldn't be going smoothly. So today, throughout this session, we are going to cover those four things. So first of all, I'm going to repeat again with what Paco said about the serverless architecture and the Azure Function stuff. Then we are talking about the three different aspects of building serverless API. So first one, second one, third one. Yeah, these are the things we are going to talk about. And if you have any questions, just ask. And if you feel shy to ask, then use this link. So it's kind of a Slido, we can say. This Slido. So we will take these questions soon. So can we move on? Right. So let's talk about the basic stuff of what the serverless architecture look like. Then what the Azure Functions look like. So the first thing we are going to talk about is the nature of serverless architecture, which is the serverless architecture means we say the term serverless, so which means there is no server. No, not really. There is a server, but what I can say is there is a server, but we are not managing them. But which means a cloud service provider such as Azure, AWS, or Google, they manage all the servers and infrastructures, right? And this is actually the characteristics of PaaS, which is Platform as a Service. So that kind of thing is done by the cloud service provider, and from the business running perspective, from the user or developer perspective, we only focus on the business value. So through the code, we write in the code, and through the code, we create our business value. So that's what the PaaS and the serverless architecture look like. So this is more about the PaaS side, but on top of that, the serverless architecture has one more thing, which is the scaling. I mean, usually the serverless architecture is run by events, so event-driven architecture, which it says. And in PaaS area, we still manually set up the scaling, right? For example, if the RAM usage is like a 75% of RAM usage, and we are going to scale out. Or if the CPU usage is like 90% of something, and we need to scale up, something like that. So these kind of the scaling settings should be done manually. This is the PaaS world. But in the serverless architecture, actually, this kind of scaling also done automatically, which means the event comes in, like flooded in, such as like this university, at the beginning of the semester, all the students going into their online enrollment system, and the server will be flooded out. On that case, the server is automatically scaled out. Then, after the enrollment is over, then it automatically scales in, even into 0. So that's something we can say that's the characteristics of serverless architecture. So in that case, cloud service provider, there is no way to charge us, actually, because there is no server we can manage. There is no PaaS instance we are managing. So the only way they can charge us is the execution. So how many number of executions we made, and how long the execution takes, right? So these two aspects is what the cloud service provider charges. So which is very cheap. So as long as we are not using our application and we are not charged, which is good. And yeah, so let's move on to the nature of the Azure Functions. The first two things I'm going to talk is about, actually this is in the serverless architecture in general. So for example, as I said, all the serverless application is event driven. So event can be anything, such as HTTP trigger, request, or timer, or all other types of the service bindings. Particularly in Azure area, maybe the service bus message, or event grid message, or like any sort of things like the blob storage, the files copied into something like that. Any kind of event can trigger Azure Functions. Now, and also theoretically, ideally, we can use any programming languages on Azure Functions, even in other the serverless applications. But in reality, we have restricted, limited number of languages we can use, such as the C#, F#, Java, Python, and JavaScript, and something kind of things, right? And so the first two things are about the general characteristics of serverless Applications. Now, we are talking about the Azure Function specific features. So Azure Functions is basically the Azure App Service. So it's running based on top of the Azure App Service. So we can make use of pretty much every features available on Azure App Service, plus Azure Function specific features, such as the Azure Function proxy, some kind of things. Also, the good thing of Azure Functions is it supports cross-platform, which is Azure Functions can run on Windows, Azure Functions can run on Linux box, and even in some other operating systems. And the good thing is the logging and monitoring. So Azure support has an offering for application insight, which is for the logging and monitoring purpose, and Azure Functions is seamlessly integrated with application insight, so we don't have to worry about it. As long as we put instrumentation key onto Azure Functions, and we don't have to worry about anything. They just do automatically. So now we have walked through what the nature of Azure Functions. So what exactly Azure Functions do? So let's think about this. So actually there are three things here. So as name said, function. So function actually has three different perspectives. One is input and do something, process, and returns output, right? So input side is event. So any event can execute function code, right? So event can be, as I said, HTTP trigger, webhook, timer, or blob storage, or the event hub, or service bus message. All sorts of things can be event, can be an event, right? And those that act as an input, then we do write the code side. So we can write the code in any languages such as C#, F#, JavaScript, Java, Python. Nowadays, I think this morning, the Microsoft announced that we are supporting PowerShell, something like that. So, yeah, we only do the coding part. And so once code is done and the business logic processed within the code side, within the function, then it returns outputs as like HTTP response or notification hub or database or message, another message, something like that. So these are basically the concept of function and what the Azure function do. Right? So we have talked about the language side. So let's go into a little bit deeper. So in version 1, Azure function, in version 1, the Azure function used to support C#, F#, and JavaScript, but it's quite hard to add extra languages. So such as Java or Python, it was very experimental, but it was really hard because the host runtime process and language process were tied together. But in version 2, they internally separated the language process runtime from the host process runtime. Right? So host process runtime is basically the basic, the Azure Functions runtime. It takes care of all the inputs, right? Through web host, it takes an HTTP request, which is a little bit separating, and all the other things is script host runtime can handle all the other types of the inputs. And within that script host, it actually looks for all the language process runtime, which can be either Node.js worker, Java worker, Python worker. So by changing this architecture, right, into this type, then we can add extra languages. Only we can put the language worker onto that. Then it automatically loaded up into the host process by running the IPC server. That's how internally working. So if, for example, if the node language worker is crashed or down or something, even though that language runtime is not working properly, but the main host process is still working. So the Azure function runtime is still stably running. So if we are not, so as I said, if the Node.js language runtime is crashed, so as long as the function endpoint or function is written in the other languages, then the triggers are not affected. So that's how the host process and the language worker process is separated. So let's talk about the 3 different aspects of building serverless API. So what we have done so far is to look into the internal, how internally the Azure function is working. Now we are going to say about how to build serverless API more effectively and efficiently with 3 different aspects. So the first aspect would be the portability, which is we can, and Azure Functions actually is very good for support those 3 things. So portability means Azure Functions runtime can be deployed or can be run on any circumstances, not just for Azure, but for the other cloud service provider as well. And the second one is testability, which is before deploying the application, we should be able to test within the isolated environment, right? By doing a lot of the dependency management. And the third one is because this is an API, right? So API should be discoverable by other applications or other machines, something like that. So those 3 aspects is the key of building serverless API, right? And as I keep saying serverless API, not serverless application, because we are only focusing on HTTP trigger, which is mainly API. So, but in general, we can apply those things into other type of the triggers. But throughout this session, we are focusing on the HTTP trigger side. Okay? So, start on portability. So, as you can imagine, portability is done by containers. So, Azure Function supports cross-platform runtime. So, which means, as I said, we can run Azure Functions runtime on any platforms, any operating systems, even on any, any CPU architecture, such as Windows, Linux, even on a Raspberry Pi or something like that. Okay? So, and those languages listed here are supporting the cross-platform languages, cross-platform runtime, which is ASP.NET Core, Node.js, Java, Python, and so forth. And also, the Azure Functions is infrastructure independent, which means we can run Azure Function runtime on any different environment. For example, Azure App Service environment, on Service Fabric, or as AKS, as a Kubernetes service, or even we are building our own Kubernetes cluster, we can run Azure Functions runtime. And even we are using the Raspberry Pi, such as this, so we can use this Raspberry Pi as well to run Azure Functions runtime. Now, also, that Azure Function runtime, when we create the package that Azure Functions, then it can be deployed on any cloud service provider, such as Azure, AWS, Google, even Alibaba, any sort of cloud provider, as long as they support container technologies, right? So basically, we are packaging all our runtime on Docker or Hyper-V. So these are the Azure Functions. So there are many hosting options, the Azure Functions. The left-hand side, when you can see, is mainly managed by Azure, and right-hand side is mainly managed by us. So first option would be the typical serverless function. So the gray area is managed by Azure, and the white area is done by us. Oops. So we only take care of code side. All other environment is done managed by Azure. Okay. So the serverless Linux functions, and that's also the one option. So operating system is changed from the Windows to Linux, and the infrastructure is app service environment into Service Fabric, and the Docker daemon, it runs on Docker daemon, and we just deploy our code, the same code. And also the same thing, but instead of deploying the web deployment package, we just package within the container and deploy it. So that's function containers. And also, we can run these as a functions on AKS, as a Kubernetes service instance cluster. And even we can build our own Kubernetes cluster and run that thing on, run the Azure Function runtime on there. Now, so we can run Azure Function runtime within the IoT devices, for example, the Raspberry Pi, something like that. And in this case, everything needs to be managed by us. And even if you are really into, okay, I want to run Azure Functions runtime on our on-prem server, then this is another option. So in that case, regardless of our function code is running, and we can port one place to another. So these are all possible the hosting options. So whenever, wherever you want to move from your functions runtime one place to another, yeah, that might fall into one of these 7 options. So let's do some demo here. I'm going to run this, the Azure Functions runtime on Amazon ECS. Okay, so this is the Amazon, the ECS cluster. So let's get started. Okay, so oops. Oh yeah, not surprising. So we create custom images from I already created the function the container image from and uploaded onto Docker Hub, so we can just simply use it. com/function app. Okay, so com/function app Linux x64. Oops, that's the one. That's this. That go here. GAB 2019, and everything leave as default and 80 port number. Now, so we use this, then yeah, everything will be left as default. So load balancer and create default and next. So create. So yeah, it will create all those things. I think it takes a little bit of time. So instead of waiting that, we are moving to another demo. So the next demo would be the Raspberry Pi things. So let's talk. So this is the one. So I'm running. I took a video from here. So from my screen. So this is how Raspberry Pi is boot up and running. So I put the username and password here. And within there, it has already the Docker container images here. So it shows the Linux images, the ARM images, and it's already running the containers here. So simply remove that for now. Then it's running. So run this the Azure Function runtime on the Raspberry Pi the device. So it runs like that. Oh, I'm typing very slow. So once it's done, and it starts up and running, something like this. So actually, this application, so this Raspberry Pi device has already that. So if you are interested in, go to this Docker Hub and play around this. I will get this the repo at the end of the session anyway. So bear this in mind. Now, so instead of doing that, let's do. Okay. So I run this one. So this is my Raspberry Pi. Now, so it has, it has currently this image. What is it? What's the name of this? Docker run ITP Oops. What did I miss? Oh, yeah. Could you Docker run -t, Docker run p name. I think that should be fine. Oh, not this one. Okay. What am I missing? Should I? Is it double dash? Oh yeah, here we go. Oh. So it takes time. So let's wait for that until we are waiting. So the Amazon ECS has done. So when we go there, so we can see the Azure Function runtime is deployed onto Amazon ECS. So function is up and running on the Amazon. So if I run this the application onto there, so we can see the Azure Functions runtime is deployed onto Amazon, then is successfully up and running. So now back to the So as you can see, the Azure Functions runtime is successfully running on the Raspberry Pi. Now we are running on the same thing in here. So as you can see, so the same thing happens on the Raspberry Pi side. So what we can see is for now is we can run the Azure Functions runtime not just on the Azure side, but also can run on Amazon or other cloud service provider, even on the other IoT devices. This is the one. Now, so let's move to the other slide. So what we can see is we can run the Azure Functions runtime on any other the places, but it has challenges. It has challenges, which means we can only run these Azure Functions for HTTP trigger at this stage. And even durable functions, even the durable functions uses the entry point as a HTTP trigger, we cannot run durable functions at this stage because those durable functions and other bindings, other triggers are relying on the storage account, which is Azure specific. So until this, the Azure storage account is decoupled, then we can only use HTTP trigger at the moment because the storage account is used for storing the state data and some sort of the locking and the coordination kind of things, right? For example, timer trigger. Timer trigger, in order to run timer trigger, we have to know when the timer was run beforehand and when this timer trigger is going to run next time. Some kind of that state has to be stored into somewhere. This is the storage accounts, right? So if Azure Functions team decouple those storage accounts from the Azure Functions runtime, then all other the triggers can be run within the container side. But if we are using, we can still use container within the Azure environment, right? Because within the Azure environment, we can still use the storage account anyway. And the other thing I didn't mention in this slide is about authentication. So if we use container, we cannot use the function's default the authentication keys, right? So if we use the functions, we usually put the the code is like a function key, right? But in this case, we have to change that access key into the anonymous. Then we should build or we should implement our own authentication method within the function runtime. That's the challenges in here for now. So that's it, and we are moving to the testability side. So as I said, we before deployment, we need to able to test all the code bits, right? Usually, the serverless application is should be deployed for testing, like integration testing is available, but not for unit testing. Very hard for unit testing and very tricky, because the Azure Functions we are using the C# code now. So the in the C# code, when you see that, the function class and the function endpoint has a starting modifier, right? So, you know, there are 3 different types of dependency injections. One is constructor injection, which is the most recommended one. The second one is property injection. The last one is method injection. So, because of that starting modifier, we can't use constructor injection because it's not instantiated, right? So we have to use property injection at this stage, and some of you guys might prefer using the method injection, but I wouldn't recommend using that. And the good thing is recently, in January, the Azure Function team removed the starting modifier. So we can start using the constructor injection. So it was very good news. But from March, they actually disabled that feature again. So I think I asked Jeff Holland from the Microsoft product team about this the change that because that the removal is unofficial yet. So until the official announcement is made, they simply disabled for now. So I was very excited, but kind of disappointed. But that's fine. We can still use other dependency injection method anyway. So let's talk about the property injection. So this is the traditional or typical approach of the unit test on the Azure Function side because of the starting modifier. And if we want to use the dependency injection, and we need to use service locator pattern in here. I know this service locator is kind of anti-pattern, but there is no other choices for now. And the good thing is this property injection supports both the version 1 and the version 2. So still some of the libraries are only, even Microsoft only support version the .NET Framework, not .NET Core yet. So in that case, we have to stick on the version 1 side. So the property injection supports both version 1 and version 2, which is good. And also the good thing is when you read the Microsoft, the Azure Function team's blog post articles or something like that, they actually use property injection method. So if you are if you have a good catch, and you will probably aware that they use property injection anyway. So it's kind of, it's unofficial, but it's kind of a recommended approach anyway. And this is a recommended approach until the constructor injection becomes generally available. So, so let's talk about so how the Azure Functions, the dependency injection look like. So this is the code bit. This is the HTTP trigger. And as I said, they are all having the starting modifier, right? And here, I add the property, static property here. And through this property, we can add, we can inject dependencies. And all the dependencies are registered in this IOC container, which is this. So within this, the IOC container, actually this comes from the ASP.NET Core, the dependency injection, the approach. So which is using the iService collection. So we can use singleton, we can use all other transient the dependencies here. And the good thing is this kind of HTTP client. So as you can see, HTTP client, it should be used as a singleton. Otherwise, it actually sucks up your memories whenever it is executed. So it's always good the practice to put HTTP client as a singleton whenever within the functions to use this singleton instance. Right? So we register all the dependencies like here, and it is instantiated through these the functions. And as you said, this is the properties. So we can inject those functions later on. And within the function, so we just simply use the create the functions, and the function instance and invoke that function instance, which is stored in this part. So all the functions here and all the dependencies are managed here. And also if, as you can see, these are all the interfaces. And these are all the interfaces. So which means we can easily mock those instances. So this is the test code, right? So we use mock. So this is the interface. We use mocking approach to to handle all the fake data in here, and the functions in here, and so this factory is the mocked instance, and we just put it as a dependency, right? And simply run this. So if we change this something in here, like this, then actually whenever we test it, something like this, so it will fail, automatically fail, like this. Then if we change this bit into true or something, then it passes the test, right? So this kind of live testing or TDD approach can be very useful if we actively use the property injection for your function code. And these are all managed within the iOS container, okay? So this is how we are managing dependencies on the Azure Function side. Now we covered the portability and testability. Now this time, we are going to talk about discoverability, which means we are using the Swagger or Open API definitions. So some of you, actually many of you might have heard about the Richardson API maturity model. Yeah. So API maturity model says it has 4 different levels. One is the lowest level is level 0, which is basically about when we call API, it returns all the business domain. So it doesn't change anything, it just returns everything. So it's very kind of vulnerable because we are exposing all our domain logic or domain data to the client. So at the level 1, we mapped those business objects into something, right? So we only return that mapped object, which we get rid of all the business specific or business the sensitive information. But still, it's not idempotent. So we introduce HTTP method such as get, post, put, or something. Those kind of things is introduced. So we can now achieve the idempotency here. So basically, the Swagger kind of things is achieving this level 2. But on top of that, we actually need to provide some sort of navigatability. So which we can call as HateOS. So HateOS, and one of the HateOS method is HAL. These kind of things, the library can be added to support navigatability. So when we say discoverability, we actually are expecting to achieve this level 3. But navigatability achievement is something different. So at least we are meeting this level 2, that actually what Swagger currently does is that's okay. And maybe Web API design maturity model is referring to quite similar thing, but using the different terms. So level 1 is database centric, which is basically a business domain. Level 1 is object centric, which is mapped object. Level 2 is resource centric, which is using the HTTP verb. And the affordance centric is to achieve the HateOS navigatability. So as I said, this is the ideal thing, but the level 2 achievement is okay. So based on this idea, where is the Azure Functions now? So Azure Functions doesn't support level 3, the out of the box. We should install our own things using the library or whatever method we use. But in the level 2, it's kind of partially supported, which means in version 1 of Azure Function, the Swagger definition is partially supported. Yeah? So within the admin area, they automatically generate as the Swagger definition, but we have to modify it for the complete use. And unfortunately, the version 2 doesn't support the Swagger UI yet, so which is a little bit sad. Now, but the good thing is the third-party libraries are available out there, so we can use that third-party library to achieve the discoverability. So what that is there is an open the Azure Functions extension library called Azure Functions extensions. So if you like, go to the use the QR code and to visit there. So it supports both OpenAPI version 2, which is Swagger, and version 3. And also this library supports Swagger UI. So if you have already used the Swashbuckle on your .NET on the ASP.NET application, and this library will give you a similar the experience to the Swashbuckle. And also it supports both version 1 and version 2, so which is good thing. So yeah, let's see about the Swagger UI, how that Swagger UI is implemented on the Azure Functions. So back to the same thing. Now, this is the OpenAPI one. So when you see that, so this is OpenAPI HTTP trigger, as the name says. So it has two endpoints. One is Swagger, and the other one is Swagger/UI, right? And so this is not just that. So if we want to expose the endpoint into the Swagger, and then we should add those decorators. So operation will be the list, and this takes these parameters within the query string or within the path, within the header or something like that. And also it has the return response payload of looking like this type of application. So basically, this decorator approach is very similar to the Swashbuckle. So you will have the similar experience, right? So when you build, let's build this application. So that application is running. Oh, runtime is updating. Okay. Wow. Why now? Oh my God. Oh my God, just before that, 1 hour ago it was fine. Okay. So yeah, my internet connection is stable, so wait for that. Okay, while waiting, so we can actually, what about waiting, what about using this, the Raspberry Pi application? So actually, we can use that. So this is the Swagger UI. So the code I showed you is exactly the same as the containers, right? So, oh, it's running now, okay? So let's put this aside. So this is the Raspberry, oh my God. So this is some Raspberry Pi application in here. Now, oops. So basically we have this Swagger UI. As I said, as I showed you in here, so this is a Swagger UI, this endpoint, right? This endpoint is actually showing that. And so, okay. So localhost, okay. So now we are working. Right. So this is basically it. And yeah, as I said, this is the same, the Swagger UI, so we can run, yeah, within this UI, right? So also, it provides the Swagger definition like this. And if we are running this application, actually it supports both JSON and YAML as well. So it returns YAML definition as well. Or if you are interested in using, okay, I want to use the OpenAPI version 3, then we can, oops, hello? 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 Okay. Yeah, can you hear me? Yes. Yeah. So if I want to use version 3 of API definition, then we can simply use this, right? So use this the third-party library extension for as a function extension, then your as a function API turns into the real API so that other applications or machines can discover your all endpoint, right?
Are you using swashbuckle behind the scenes?
No, it's not swashbuckle. So it's the community library. I made it. So so yeah, it's kind of a good. It gets a lot of attention from the other developers. So we can use it. So it's a simple the NuGet package library. So you can just edit and use write some a bit of code of this definition. As I said, so add these decorators, then you will this endpoint is turns into your coming up onto your Swagger UI. And in order to enable this, this code needs to be written by yourself. But this one of the bucket for this improvement is as long as you implement this library, you can automate that. We don't have to write this anymore. So that's something I can do for over the next couple of weeks. So anyway, so yeah, have a try this. Now, so we have covered those things. The first one we have the look through what the serverless architecture look like and how the Azure Functions works and internally and how language process is working. And we touched it 3 different aspects. One for the portability, and the second one is testability, and the last one is discoverability, which is using the Swagger UI. Right? So with these, if we use these 3 the aspects on your when you are building your serverless application using Azure Functions, then your API will be pretty much very portable and very much you can do anything on there. So if you are really interested in what we have discussed so far, is visit this the pages. The first one is the source code, what I have shown this session. So it will show you how dependency injection works and how the Docker file look like, and how the OpenAPI extension is implemented. Right? So use this the repository as a starting point. And if you want to run the Docker container in your by yourself, then the Docker container repository will be your point to visit. And the third one is the OpenAPI extension library on GitHub. And I have written a blog post around this. So if you are interested in visit those things. Right. So I think that's the one. Do we have any questions?
Which testing framework do you use?
Sorry?
Any framework we can use for the testing, the Azure Function?
So the question is for the testing, so we can use any testing framework. Is it the question? Yeah. So as long as you are writing your code in C#, then you can use any testing framework. So the good thing is no questions here, and time's running out. So any questions?
Are there any license implications Open source, free, you can use anywhere.
What do you mean by?
Azure Functions.
Yeah, Azure Functions.
Run it on any platform.
So Azure Function is basically open source and MIT license, so we can run anywhere, and we can actually you can modify that code by yourself, yeah, without having to feel bad. Any other questions? Okay. So thank you for coming. My name is Justin, and yeah. Thank you.